6. Pretty straightforward, easy stuff. I would recommend if you're on a test or something, do this twice. Sometimes you may make an error in your calculator putting it in. There's no rush. You have the time, so just do it properly. Median. Median is the middle term, the middle number. So we have 10 numbers, remember? So it's going to be around the 5th number. So 1, 2, 3, 4, 5. This is the 5th number this way. 1, 2, 3, 4, 5. This is the 5th number here. And if you remember correctly, if there was an even amount of numbers in your number set, then you have to take the average between the two middle terms. So they're going to be exactly two middle terms. In this case, the two middle terms are 85 and 73. So take the average of 73 and 85. Let's add them together, divide by 2. Which is what? Let's do it. 73 plus 85 divided by 2 is 79. So the median is 79. And the mode is the easiest one. It's the one number that repeats the most. Now, if there are no numbers that are repeating, then the answer is there is no mode. But in this case, the mode is 85. Very easy. Easy. The range of data is very simple. The range is from 22 to 95. It's just from the smallest to the biggest. That's it. Easy stuff. Yeah, time enough for one more, I think. We got some probability. Probability is a measure of how likely something is to occur. It is expressed numerically in one of 3 forms. If you remember correctly, we got a percent. So you can have 0%, 1%, 10%, 11%. Usually it goes up to 100%. You usually don't go past 100% when it comes to probability. Then we have a fraction between 0 and 1. So you can have 1/2, 1/3, 1/4, 1/10, 1/100, 1/1000, whatever fraction, as long as it's between 0 and 1. And then the decimal between 0 and 1. So 0.1, 0.153, 0.282, 0.08, 0.92. Decimal, right? Between 0 and 1. Easy stuff. Theoretical probability represents the likelihood of an event occurring in the ideal world. So theoretical is the one that we use our math to calculate the probability of something happening. Experimental probability represents the likelihood of an event occurring based on actual trials conducted. So this is when you've done experiments or you've recorded data and you've found out the chances of something happening based on your data. And then theoretical probability tells us what we should expect to see. Experimental probability is what we saw. So there's a difference. So the real world doesn't always act the way we expect it to. Sometimes there's other variables that we don't take into account, or sometimes people are just maybe get super lucky. Who knows? Like if you're flipping a coin 10 times, maybe you get 10 heads. Something crazy happens, and then every time you flip, you just keep getting heads. Either cheating or you're lucky. All right, Jim rolls a standard 6-sided die. Determine the probability of rolling the number of 2, an odd number, a number less than 3. Okay, we have time enough to do this. Pretty easy, pretty straightforward. We got Jim. He's rolling a die. Because dice is plural, and we're just rolling 1. So the number 2. The way to do this is to realize, well, you know what? We have how many possible outcomes? We have 1, 2, 3, 4, 5, 6. 6 possible outcomes, and each have exactly the same fair chance of happening. The number 2 is 1 out of 6. Meaning that is the probability, and you can rewrite 1 out of 6 as a decimal. Just do 1 divided by 6, and you'll get 0.166666. So we're just going to round that up to 1.166666. 7. Or you can write it as a percentage, which is 17%. Remember, to go from a decimal to a percent, you just times it by 100. That's it. So 3 ways of writing it: fraction, decimal, percent. What about an odd number? What are the chances of Jim rolling an odd number? Well, let's see how many odd numbers there are possible. And if you said 3, you'd be right. 1, 3, and 5 are odd numbers, and there's 3 of them. And there's 6 possible numbers or outcomes, and 3 of them are odd. So it's going to be 3 over 6, which is also the same thing as 1 over 2. Also, it's 0.5, or written as 50%. So once again, fraction, decimal, percent. A number less than 3. How many numbers are less than 3? Well, there's only 2 numbers less than 3, 1 and 2. The answer is 2 over 6. Any other number would not be less than 3. So that's going to be a fraction of 1/3, or 0.33, or 33%. And that's how you do this. Not too bad, hopefully. You're going to recap your learning goals. Make sure you solve all the things that we went up. Now what? You should be finishing up 4.5 if you haven't already done so. Make sure you do your assignments. And then, yeah, that's about it. And then all due date, Unit 3. Okay, well, everything, not just Unit 3, Unit 3 and 4. So today's the last day to submit anything. Well, yeah, you guys understand that. All right, that's it. Any questions?